Endodontic Challenge. While we are waiting for the participants to join the session, I will introduce you to our company. DentistChannel.Online is a digital dental media company. It is your marketing solution for dental events, product launches, workshops, and courses. We also provide a collection of scientific articles and blogs about different topics in dentistry. We work hard to be your first-hand information on the technological advancements in the dental field. Now it's time to start the session about NiTi instrumentation of root canal systems, the Endodontic Challenge. If you have any question about this topic, please feel free to ask it in the question and answer box, and we will answer each and every question at the end of the session. I will start by introducing today's session speaker, Dr. Alessio Zanza. Dr. Alessio is a doctor of dental surgery and a PhD student in innovative technologies in disease of skeleton, skin, and orocraniofacial district at the University of Rome. He started his scientific career when he was still a student. In 2021, when he was at the 6th year of degree course, he managed to publish as first author an important research on one of the most relevant journals in the field, Journal of Endodontics. To date, he collected a H-index of 8 and more than 130 citations. His field of expertise is endodontics and in particular the NiTi endodontic instruments. Welcome, Dr. Alessio. It's our pleasure to have you with us.
Thank you very much for the introduction. I would like to thank you for the invitation and thank you for giving me the floor. So when we are ready, I can share my screen and start the presentation.
Yes, please.
Okay. So good morning, everyone. Today we will talk about the endodontic channel, and particularly in the first part of the presentation, we will talk about the theory behind the clinical practice, and then I give you some tips and tricks, some protocols to face the most of cases during the endodontic treatment. So let's start with the presentation. First of all, I sum up some basic things about endodontic rotary instruments, beginning from the tip of the instruments. As you know, the tip of the instruments, endodontic rotary instruments, particularly NiTi endodontic instruments, are non-active. The tip is non-active. So we have different diameter according to the ISO standardization. You see the code color according to which the diameter tip is selected. Another characteristic of NiTi endodontic rotary instruments is the file length. And second, the taper. The file length is formed by an active part of 16 millimeters, a shaft of different length according to the total length of the instruments. The taper is very interesting because with this we can manage different situations, particularly in the coronal part, in which we can reduce the removal of dentin, in particular in the zone of the pericervical dentin that is fundamental to the fracture strength of endodontic treated teeth. Other two characteristics in the longitudinal part of the instruments is the pitch and the helix angle. The pitch is the distance between two consecutive blades, whilst the helix angle is the inclination of the blade in relation to the longitudinal axis. All these characteristics are fundamental because they influence the mechanical behavior of NiTi rotary instruments, and particularly in relation to the cutting and to the fatigue and torsional resistance. According to the transversal characteristic of our instruments, we have different cross-section, as you can see in this scanning electron microscopy. You can see that the cross-section is cross-section are variable, different geometry, different characteristics, so different mechanical behavior. The rectangle, on the contrary, is the inclination of the the cross section according to the root canal walls. So the inclination of the blade in the transversal way, and it influences in a strong way the cutting efficiency of our instruments. So this is a brief summary of the most important characteristics of our instruments. But let's talk about why NiTi is the material of choice for our instruments, for the manufacturing of endodontic instruments. First of all, we have to cite this interesting article about the introduction of NiTi in the manufacturing of rotary instruments in substitution to the stainless steel manual file. In this article, those colleagues highlighted the main drawbacks and limitation of the manual instrumentation in relationship to the stainless steel manual file. And they are fundamentally their stiffness, low flexibility, and obviously not super elastic behavior that could lead to iatrogenic error, such as apical zip ledge and perforation. So with the substitution of stainless steel alloy to the NiTi alloy, we have obviously different metal characteristics. Despite this, the principle of endodontics have never changed, because the 3 key points of our treatment are undoubtedly the chemomechanical disinfection of root canal system, stability of apical and coronal obturation. So if we remove all bacteria inside the root canal system, we can achieve great success during endodontic treatment. Obviously, with the introduction of NiTi systems, we reduce the time of endodontic therapy, simplify our root canal instrumentation, and increase the success rate of our therapies. But why nickel titanium is the material of choice for the manufacture of endodontic instruments? First of all, for their superelasticity. The superelasticity is fundamentally the ability to be reversibly deformed to very high strains, up to about 8%, without being plastically deformed. So if you see the graph on the left of the screen, you can see the transition between the crystallographic phases according to the stress induced. So we have in the conventional NiTi instruments, we have austenite that after the loading could be transformed in martensite, until a point that when we remove the stress, the stress-induced martensite returns in the austenite forms. In the graph on the right, I'm sorry, you can see the stress and strain curve of stainless steel and NiTi in comparison. We have hysteresis over there, in which the NiTi, in which we can explain the NiTi behavior according to the submission of stresses. Another fundamental characteristic is the possibility to have the NiTi alloy in 2 different crystallographic phases. The austenite, that is stable at Eiget thin protein, is formed by this structure. It is stiffer and shows superelastic behavior, whilst martensite has shape memory effect, so a reduced superelastic behavior. It is stable at lower temperature than austenite, but it is flexible and has an improved cyclic fatigue resistance. Between these 2 phases, there are the air phase, that is a sort of hybrid between austenite and martensite. All this information is fundamentally to understand why we can use these instruments. I know that this information are very boring, but it is fundamentally to select the proper instrument during the root canal treatment. So the austenite and the martensite switch continuously between them. So we have 2 possibilities to have transformation, and the first one is related to the temperature. So we can transform austenite in martensite, giving some cool to our instruments. So if you heat the martensite, it will be transformed in austenite. The second possibility to transform austenite martensite and vice versa is the stress. If we submit austenite to stress, the austenite transforms itself in stress-induced martensite, and all these transformation are reversible. Okay, so as I said before, the NiTi alloy is conventionally stable at high temperatures. So in the intracanal situation, intracanal temperature and ambient temperature, we have in the conventional NiTi just instruments in the austenitic form. But with the introduction of heat treatments, the NiTi could be stabilized in the martensitic crystallographic phase, even at clinical and ambient temperature. So if you see the hysteresis diagram in the right part of the screen, you can see that above certain temperatures that are dependent on the morphological aspect of the instruments, we have the 100% of austenite. So above this temperature that is related to the specific instruments, we have just austenite. Cooling the instruments, we are in the starting point of the transformation in martensite. So progressively, we have the transformation of austenite in martensite until the reaching of this zone, that is the finishing point of the transformation of martensite, in which we have the instruments totally formed by martensite, and this passage are all reversible. So this is a sum up of the most important instruments in the market and their relation to the crystallographic phase at ambient and intracanal temperature. So if you want to take a photo, you can do it. And this is the heat treatments and where they are placed in the curves. So despite the obvious improved mechanical properties of NiTi, the fracture can still occur, and this is one of the major concerns of endodontics. The two main causes of intracanal separation are excessive cyclic fatigue and excessive torsional load, with a percentage that can vary from 1% to 10%, and a consequent degrees of success rate ranging from about 20% and 50%. Obviously, the fragment of an instrument doesn't compromise intrinsically the root canal treatment, but as we can say before, the endodontic treatment is related to the infection. So the instruments is just a part of is an object inside our root canal system that could limit our disinfection and irrigation operation procedures. So the two typical tractographic pattern of separation of NiTi instruments are the cyclic fatigue and the torsional loads. Those are some micrographs acquired by the scanning electron microscope. We see the fragment of an instrument arising from cyclic fatigue failure. So the cyclic fatigue is an inevitable direct consequence of the rotation of the instruments in the root canal curvature. So they are subjected to strain cycles of tension and compression. And once the elastic limit of our instruments are overloaded, we have the plastic deformation and then the fracture. This is the fractographic pattern. As you can see, the fracture starts from the external surfaces of the instruments and propagate itself in the center of the instruments, causing adductive fracture. On the contrary, the torsional load is the fracture arising from torsional load occurs when the tip of the instruments, the most vulnerable part of the instruments, is blocked in the dentinal wall and the coronal part continues to rotate. Once we have overloaded the elastic limit of our instruments, the instruments going to the fracture, goes to the fracture. And the fractographic pattern is totally different in comparison to the cyclic fatigue resistant fracture. As you can see in the center of rotation, we see the dimple and fibrous surrounded by the circular abrasion marks that state the rotation of the instruments and the failure according to this. So one of the most important things of instrumentation of root canal system is prevent the instrument fracture. We have 3 different levels of factors that could influence the mechanical properties of our instruments. First of all, the anatomical factors, but we can just visualize it before the root canal treatment and select the instruments according to the anatomical situation, because we can change the anatomy of the tooth, but we can modify our treatments according to this. The second group is the instruments related factors. So all characteristics of the instruments in terms of morphology, so diameter, cross section, and all the characteristics that we have seen before. And finally, the instrumentation technique. So how we can use our instruments. So let's talk about the anatomical factor. Obviously, the knowledge of endodontic anatomy is fundamental before starting every root canal treatment. According to the cyclic fatigue, the radius and angle of curvature is fundamental, because we know the literature stated that increasing the angle of curvature and reducing the radius of curvature, our cyclic fatigue resistance is lower. We have to check the confluences, because as we can see in these cases, there are 2 canals, the mesiobuccal and mesiolingual, that confluence in the apical part. Obviously, we have to select the first canal that we have 2 instruments, because if we manage, first of all, the mesiobuccal canal, as you can see, we have to face a double curvature. Instead, if we face before the mesiolingual canal, we have a long curvature with a lower angle of curvature and radius of curvature. So if you have the possibility to analyze the anatomical features of our tooth, obviously is a great point to start our treatment. So the canal length is obviously another factor that could influence our cyclic fatigue resistance. Regarding torsional resistance, the canal diameter and the dentinal hardness are the most important things that can influence our mechanical behavior of our NiTi Rotary instruments. Again, radius and angle of curvature. As we can stated in this article published in 2020, we demonstrated that torsional stress and cyclic fatigue are can be considered as 2 distinct phenomena, but they interact each other. And we demonstrated that the torsional resistance is fundamentally related to the flexural stress acting on our instruments. So depending on the anatomical features of our or anatomies. So in this article, we stated that the total torque, so the torque at fracture of an instrument, is obviously dependent on the torsional load that is represented with the letter T, but also is dependent to the bending moment acting on an instrument. So depending on the flexural stress and thus on the anatomical features of our tooth. Another characteristic, obviously, the canal length, but let's talk about the instrument-related factor. The cyclic fatigue is fundamentally influenced by the metal mass and the heat treatment. The metal mass is fundamental because the lower or the bigger the metal mass is, the lower the fatigue resistance is. According to the crystallographic phase and so the heat treatment, we can state that the martensitic instruments obviously are more resistant to cyclic fatigue failure because of the metal characteristic that we explained before. Talking about the torsional resistance, the concept is not so easy. During the last decades, there have been many theory about the most important instruments-related factor that could influence the torsional resistance. First of all, the file size, the stiffness, and the file size, the diameter, the cross-sectional section, the central core area. But all these theory are not fundamentally approved by the scientific community until this publication from our research group, in which we changed the paradigm of the torsional stiffness and so the torsional resistance of NiTi rotary instruments. In this article, we demonstrated that it's not important the mass or the area in relationship to the torsional resistance, but how they are spread far from the point of rotational center. So the concept could be traduced in the concept of polar moment of inertia. In other words, basically, the more the mass and the volume are spread far from the rotational center, more the torsional resistance is. Obviously, the torsional resistance is related to dynamic factor because we have torsional load during the cutting of our instruments. So the rake angle, the helix angle and pitch, tip conformation, rotational speed, cutting efficiency are all factors that could influence our torsional resistance. According to the instrumentation-related factor, we have different strategies that we can adopt to reduce the stress during our instrumentation. Obviously, the access cavity is one of them, because increasing the angle of access, the cyclic fatigue resistance of our instruments reduces, and the torsional resistance, on the contrary, increases. So we have to select the proper instruments also according to our access cavity. If we want to perform constricted access cavities, we have to select in the first phases martensitic instruments because they are more flexible and they are supported by the increase of torsional resistance depending on the increase of flexular moment acting on the instruments. Pre-flaring and glide path are two fundamental steps of our instrumentation. Performing pre-flaring and glide path, we have a notable reducing of our stress. These are some graphs about the torsional torque, at which the instruments are subjected during the instrumentation without and with glide path. with glide path, we have lower stress acting on our instruments. Obviously, pecking motion and brushing motion are two different techniques to instrument our canals. Pecking motion is a sort of up and down movement parallel to the longitudinal axis of our canals, whilst brushing motion is a sort of sliding of our instruments against the root canal walls. Obviously, we can select the motion, continuous or reciprocated motion, and we know that the reciprocating motion decrease the torsional load on instruments and increase the cyclic fatigue resistance, because basically it provide less round per minute in comparison to the continuous rotation. But so, which type of instruments should we select, martensitic or austenitic? We can't have a right answer to this question, because each instrument has a role during the endodontic treatment, and each instrument should be selected according to previously mentioned aspects. So every instrument is an operator-dependent choice. So there isn't the ideal instruments, but there is an ideal instruments related to the anatomical situation, patient situation, and something like that. So briefly, we sum up the phases of endodontic treatment: the access cavity, the instrumentation procedure that could be divided in scouting, glide path, preferring, shaping, and finishing. Obviously, this division is totally academic, because during our instrumentation, we don't have this separation of each phases. The scouting is the first part. The scouting is the phase in which we explore the root canal. We aim to ensure the localization of root canal, orifice, and the patency of the canal. Obviously, it could be performed with rotary instruments or stainless steel manual file. Personally, I prefer to perform it with rotary instruments, and I will explain why later. But let's talk about some terminology so we can speak the same language. So pre-flaring. The pre-flaring is the pre-enlargement of the root canal. I'm sorry, but I forgot to translate this slide. The pre-flaring is, as you can see, a pre-enlargement of the coronal part, the the coronal 1/3, in which we have straightening of our coronal third in order to face the most difficult part, that is the middle part and the apical part, with easier. The glide path is defined as a smooth radiconal tunnel from the canal orifice to the terminus of the canal. And again, it could be performed with rotary instruments or manual instruments. But we have to determine at which point we have to finish our instrumentation. And literature regarding this theme is very controversial. Obviously, the instrumentation, obturation, and irrigation procedures should finish in corresponding to the finish of the canal, to the end of the canal. So this point could be determined as the apical constriction. The apical constriction is the smallest part of the apical foramen. Another important point is the cementum dentinal junction, but it could be determined just with histological evaluation, so clinically is not significant. Another important part is the foramen. The foramen is the point of exit of our canal, and in my opinion, the instrumentation and the obturation could finish starting from the apical constriction to the apical foramen. In all this part, we can finish our obturation and instrumentation. but it is important our three-dimensional instrumentation, irrigation, and obturation. So, in my opinion, it's not important at which point in this area we finish our procedures, but the quality of our procedures are fundamental. So, talking about endodontic phases, the flaring, coronal flaring, and the glide path and the shaping are different phases academically, but which is the limit between each phases? We cannot state anything about this because these phases interact and overlap each other. So the flaring and the scouting, personally, I perform it with mechanical instruments, so rotary instruments. Why? Because some clinicians say that it is dangerous to start our root canal treatment with rotary instruments. But if we check in the literature, we know that according to the micro CT scans, anatomical investigation, and most of this article, we know that in the coronal part, a glide path, a natural glide path is established by the nature. We have a space to introduce our instruments. So we introduce rotary instruments without any danger. And obviously the phase in with this approach is very easy, very fast, and the risk of iatrogenic errors such as ledge, stripping, is very reduced. But this is my personal opinion. The second phase is the glide path and the shaping. Once again, the glide path and the shaping could be considered as one unique phase, because obviously if we have street canal, we have to segment our instrumentation with more file. But in the most of cases, the 80–90% of cases, we don't have problem related to the diameter of our canal. Obviously, if we have street canal, we have to spread our torsional loads in more instruments. So I use the glide path instruments. But if we have large canal, it is superfluous. So the shaping is the most important part of our instrumentation in relationship to the irrigation, obviously. And this is my approach to the root canal. This is my protocol. This is the ORE protocol, only rotary endodontics, because this protocol is performed just with endodontic rotary instruments. So first of all, I divide my tooth in 3 parts according to the difficulty of the instrumentation. Obviously, the coronal part is the most simple. The middle part is an hybrid from between the coronal part and the apical part. The apical part is the most difficult part to be instrumented, because in this point we have many anatomical variation, and such as curvature or something like that. So first of all, radically divided our tooth according to the difficulties. Second, pre-enlarge the instrument with an orifice opener or just with another instrument. It's not important which instrument to use, but the most important thing in the first phase is to enlarge the coronal part, because enlarging the coronal part and the middle third, we have a solution of the problem in this zone, and we can face the most difficult part without being influenced by these 2 zones. So the second part is obviously the pre-enlargement of the middle third of our canal and a selective enlargement of the coronal part that is previously instrumented with the orifice opener, but we can instrument the coronal part according to the anatomies. In other words, we can enlarge the coronal part in order to approach the curvature in the right way. So if we have a curvature on the distal aspect, we have to enlarge our coronal part in the mesial aspect of the root. So we doing that, we reduce the canal curvature and radius of curvature. So this is a tip and tricks that we can use in order to reduce the anatomy difficulties. But pay attention to the orange zone. The orange zone is the pericervical dentin. This is fundamental to the fracture resistance of endodontically treated teeth. So enlarging the coronal part, we have to maintain a sort of minimal invasive approach. So we have to remove the dentinal wall just where we need. After that, we can establish the working length. This is the only phase that in which I use the manual instrument just to check the working length. So in these phases, in this phase, I put my stainless steel manual instruments, often the 8 or 10 K file, and I determine the working length. Once I have do this step, I pre-enlarge the apical part with the glide path instruments only if it's needed, so just in case of street canals. Personally, I prefer austenitic instruments in relationship to the glide path instruments, because I think that the glide path instruments is characterized by the small diameter, obviously. Small diameter are subjected to high torsional loads, and the marked side is not able to withstand in a great way the torsional load. So I prefer to select a stiffer file that is represented from the austenitic instruments. Once we have established the glide path, we can proceed to the shaping phases. So the enlargement of the canal. So with a determined sequence of instruments, and it's not important which is, because every sequences are great, and it's as I said before, is dependent of the clinicians. So this is my approach, my protocol, and you can see here a demonstration of an extracted teeth. In the upper part of the screen, you can see chronometer, the time, in which I would like to show that the instrumentation procedure, if performed with a right protocol, are very simple and fast. This is third molar with upward curvature, and according to the time, we can perform the instrumentation of a difficult canal in about 8 minutes. So in 1 hour, we should complete the entire endodontic treatment. So the working line determination with the stainless steel manual file. Once we have determined the working length, we can use our glide path instruments. In this case, I prefer to use it because the curvature. shaping to the working length with reciprocating instruments. Obviously, the packing motion is important. The removal of the bries from the cutting blades are important because we have to avoid ledge or blockage of our canal. Irrigation between each insertion of our instruments. And then the endodontic treatment is almost done. In my personal experience, the most important things, obviously, in addition to the instrumentation, is the irrigation. Personally, at the end of the instrumentation, I activate my irrigant for 1 minute, the sodium hypochlorite, alternating with some acid like chelate of lubrificant fundamentally, and then repeat an activation of sodium hypochlorite. And this is the key of success of endodontic treatment, because the instrumentation procedure are not very difficult if we perform the right protocol. So I have finished my presentation. So I open to any questions, and I'm happy to answer you. And if you want, I've left my contact, so you can write me or an email or on WhatsApp, and I answer you as my possibilities. Thank you very much for the attention.
Thank you so much, Dr. Alessio, for this informative session. So meanwhile, I'll ask your permission to introduce our company to all the participants, and I request all the participants to kindly put their questions in the question and answer box if they have any. So this is our organization, DentistChannel.Online, Healthy Smiles, Wealthy Lives. DentistChannel.Online is India's first digital dental media company. We did webinars with more than 400 national and international speakers, many successful world implant expos, more than 700 live dental webinars, and 20 online workshops. If you're not a Prime member yet, kindly join our family to get free certificate of participation after every event and get exclusive offers and discounts on our on-site paid courses and workshops. And most importantly, Prime members will be awarded with 1 CPD CE point for each webinar. You can join our family and be a Prime member. You can check the link, it is in the chat box. And you can use my code SAR100 in order to benefit from a discount and get the Prime membership for $9 only per year. This is an example of the certificate of participation that you will get after every event. About our upcoming webinars, tomorrow at 11:30 a.m. Indian Standard Time, we have a session with Dr. Vishal about understanding oral precancerous lesions. Also tomorrow at 7 p.m. Indian Standard Time, we have another session with Dr. Ankush about pain. Let's crack the enigma. About our online master classes, we have a master class with Dr. Jaina about communication, the key to a successful dental practice, happening on March 26th from 10 a.m. until 1 p.m. Indian Standard Time. We have an on-site workshop happening in Classical Hall, Suwaida, Syria, with Dr. Salam Harfoush and Dr. Aya Abu Fakhr about basics of dental veneers and dental photography. Learn more about the success of dental veneers and how to take the best dental photos in your clinic. It will be on March 22 and March 23. Certificate will be given by DentistChannel.Online with 12 CPD accredited by State Dental Association, Germany. I request all the participants to kindly save this number and then send a message on WhatsApp with their name, so they will be added to our broadcast list and they will receive everything about our upcoming dental webinars and courses. Today's webinar is sponsored by NovaMind. NovaMind offers a full spectrum of implants and prosthetic solutions that accommodate any clinical need in modern implantology. We successfully supply highly demanded dental implants types called internal hex, tissue level, bone level, and active conical connection. Our EU production unit and product quality is appreciated worldwide. Dental implants and dental restorative solutions produced maintaining all the standards of EU medical device regulatory. Products are manufactured in Athens, Greece, and distributed worldwide with more than 1 million happy restorations. If you want to know more about NovaMind, kindly check their website. Last but not least, don't forget to follow us on our social media platforms, Facebook, Instagram, and YouTube. Okay, so now we can move on to the question and answer session. Okay, doctor. So Dr. Iftikhar is asking, you had mentioned that instrumentation and obturation can be done anywhere between minor constriction and major constriction. Won't there be a problem as the periodontal ligament is violated?
Yes, of course, but according to the last scientific articles, the inflammation are obviously present, but ends in a sort of 2 weeks after the endodontic treatment. So we can have a increase of postoperative pain and reduce the speed of healing, but it is not a problem in the long-term follow-up. But I would like to specify that I don't want to say that the operation must to termine in the apical constriction, but it is not a big problem if some cement or gutta percha goes below the apical constriction, obviously without a great amount of these materials that obviously are a problem for the periodontal ligament, obviously.
Okay, doctor, that's it. We don't have any other question. Everything else was clear and very well explained.
Thank you very much. Thank you very much. Thank you for your invitation.
It was a pleasure having you on our platform. Thank you for giving time and for sharing your knowledge and experience with us. We are looking forward to organizing more webinars with you in the future. But just a second, I think you have another.
I read. Personally, I've never obturated a canal with calcium hydroxide. Why obturation material with this it is not recommended.
Yes, right.
It is not recommended. We can talk about Zoe or resin-based materials on bioceramics, but I think it is another great topic that we can face now. But it is an interesting topic.
Yes, thank you so much, doctor, for sharing your knowledge and experience with us. We are looking forward to organizing more webinars with you in the future.
Thank you very much. Thank you very much. See you soon.
See you, doctor. Have a nice night, everyone.
Bye.